Welcome to my attempt at teaching how to do stoichiometry problems without even being in the classroom. You had a reading assignment about some of the possible types of problems that you can do with stoichiometry. And really, in that reading assignment, you learned nothing new. Even the people who actually did the reading assignment, there was nothing new for you to learn there. It's really all stuff we've done before, just given a new purpose. Finding actual masses that we can measure out in order to do a reaction, or predicting how much product that we're going to make in grams, not just moles, that we can produce. And so the first thing that you need in order to do a reaction stoichiometry problem is an equation, but not just an equation. You need a balanced equation. And so if you're not given a balanced equation, you're going to have to balance it yourself. You're going to have to either go and do it the longhand way, maybe you do it the algebraic way. Me, since I'm on limited time here, I'm going to go to my handy online balancer online and click balance. Boom, there's my balanced equation. And you get advertisements here too for earning my MBA from Kaplan University. I'm just going to put on my coefficients here then onto my balanced equation. It was a 5 there, a 3 here, and a 4 there, I believe. Let me go back and check, make sure. Yes. All right. So what that means is that really for 1 mole of propane is what this stuff is, like the stuff you use to make your hamburgers this summer. We are going to react 5 moles of oxygen, and we're going to produce 3 moles of carbon dioxide and 4 moles of water. It was from these coefficients that we developed our mole ratios. And the mole ratios are going to be key to solving these stoichiometry problems. The other conversion that you're going to need that's really important is your molar masses. But again, that's something we've been doing for multiple chapters now. That's nothing new. You guys are pros at those. So let's take a sample of what we could do with these stoichiometry problems. We could take grams of any one of these things and predict how many grams of reactant we're going to need or how much product we're going to make in grams. We could go from grams of one of these to moles of something else, or moles of one of these to grams of some of these. Really, each one they're all the same problem. You just use the same conversions. It's just a matter of how many conversions you have to do. So let's try a problem here. Let's predict how much carbon dioxide we're going to make here. Say we have some propane, and we'll say we burn, while making your hot dogs, 532.5 grams of propane. And we want to know how many grams, actually let's go to moles first. How many moles of carbon dioxide are we going to produce in this burning? And so for this, we're going to have to go from grams of propane to moles of propane. And your book shows that pretty well. We'll use the molar mass to do that. Then we'll use our mole ratio to go from moles of propane to moles of carbon dioxide. And so that's going to be just a 2 conversion problem, 3 fractions on here. Of course, we start by, very good, putting it over 1, 532.5 grams of propane over 1. Very good. And then we want to convert that into moles. Now, to find the moles, you have to use the molar mass of propane. How do you find the molar mass of propane? Well, you're going to need your periodic table. We're going to go, we know that there's 8 hydrogens. Each one has a mass of 1.01 grams. There are 3 carbons. Each has a mass of 12.01 grams. And we'll just punch that into my calculator here. 12.01 times 3, enter. And 1.01 times 8, enter. And then we'll just add those two bad boys together. Boom! That's my molar mass right there, 44.11 grams for each mole of propane. So 1 mole of propane is equal to 44.11 grams of propane. And remember, that's a conversion factor that we can write either way. We can have the grams on the top or the moles on the top, either one. For our purposes, since we have grams on the top up here, we want to have grams on the bottom over here. So 44.11 grams of propane is equal to 1 mole of propane. All right? Good. So now we've got it in moles of propane, but we want to know how many moles of carbon dioxide we could produce. For this, we need to go back to our balanced equation and use it to find our mole ratio. We know that for every 1 mole of propane, we're going to be producing 3 moles of carbon dioxide. So that's our mole ratio. And of course, you could write that either way with the carbon dioxide in the numerator or the carbon dioxide in the denominator. We want the moles of propane, 1 mole of propane, in the denominator, so that way it cancels out over here. And so you have 3 moles of carbon dioxide for every 1 mole of propane. And of course, that's what we're trying to get to right there. So this problem is done. All I got to do is punch it into my calculator. 532.5 times 3, enter, divided by 44.11, enter, gives me 36.216277 blah 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 moles of carbon dioxide that we will be producing by burning this mass of propane. Now, of course, that's a terrible answer. It implies that we know our measurement out to very high accuracy, which we probably don't. So we need to keep the proper number of significant figures. We've got 4 here in our original measurement. We need to save 4 in our answer. 36.2, there's a 6 spot there, so that rounds up to 2 moles of carbon dioxide. All right, so that's a relatively simple problem. They get only slightly more complex when we start to go from grams to grams. For example, if you're thirsty, one source of water is to burn propane, and you make water. And so you could condense that water as you burn the propane. I don't know how you do it. Good luck. But you could collect that water vapor that's produced, and you could drink that water if you're in a desert or something like that. So say you want a glass of water that's got 200 milliliters of water. 200 milliliters of water has a mass of 200 grams. So if you want 200.00 grams of high quality H2O to drink, how many grams of propane are you going to need in order to how many grams of propane are you going to need to burn to make this many grams of water? So we want to go from 200 grams of water to how many grams of propane are we going to have to burn? Looking for grams of a reactant here. So we have it in grams. We want to get it to moles for our conversion. So we take our grams and we're going to use our molar mass for water. 1 mole of water is equal to 18.02 grams. And of course that conversion factor can be written with either one in the numerator or denominator. So because I've got grams of water in the numerator up there, I'm going to put my 18.02 grams of water over here in the denominator, and my 1 mole up in the numerator. Alright, so now I've got it in moles, but it's not a 1-to-1 ratio. I've got, for every 4 moles of water I produce, I'm going to be burning 3 moles of propane. So that's my mole ratio. I'm going to use that in my step right here. I've got moles of water in the numerator, so I'm going to put my 4 moles of water in the denominator, and my 1 mole of propane up here in the numerator. Alright, and so if I stop now, this would be like our last problem up here, calculating the moles of something. But I want to know how many actual grams do I need. That's really what a chemist is going to need in order to measure something, is have it in grams. So to convert to grams, I'm going to use my same molar mass that I calculated back here for my propane. 1 mole of propane is equal to 44.11 grams of propane. And that's it. I'm in grams of propane. Now all I got to do is multiply them out. And this is where, because we have so many steps, I guarantee somebody, I don't know who it's going to be, I'm looking at you, Blake, I don't know who it's going to be, but somebody is going to screw this up. They're going to type into their calculator 200 times 44.11 times 18.02 times 4. If you do that, Blake, you are inferring that that 4 right there is actually in the numerator. You have to divide by both of these numbers down here. You could also just simplify the numerators and the denominators. I'm going to just do it all in one big swoop here, though. 200 times 44.11, enter, and then divided by 18.02, enter, and I need to type in divided by 4, enter, and that gives me 122.391, and I have 5 sig figs here, so I can say 5 in my answer. That's going to be 122.39 grams of propane, which I'm going to have to burn and then collect every single water molecule to make my 200 grams of water, which of course would be very difficult. We are assuming what here? Very good. We are assuming ideal conditions, which would be very hard here to trap every single bit of water vapor produced as that propane burns. So that's how you do these stoichiometry problems. Your homework is going to have you doing all sorts of different stuff, going from grams to moles up here like we did, going from grams to grams on many problems, going from moles to grams perhaps, and going from one reactant to another reactant. How much reactant are you going to need to consume the other one? Other problems will have you taking a reactant and then predicting how much product you're going to make. It's going to vary from problem to problem. There are a whole range of types of problems you can do with these because there's a whole range of different uses for stoichiometry. So do a good job on your homework, and we will be grading it actually on, let's see, tomorrow's Wednesday. Lab on Thursday. We'll actually be grading your homework on Friday because we're going to be using some stoichiometry tomorrow to predict a product and then see how close we come. All right, so we'll see you tomorrow, lab day.